Cool. So Angular performance, we'll keep the topics I'll go through in this are going to be really short. I don't want to go into too much detail with them. It's more kind of pointers to go to whenever you feel like you're hitting really big performance issues. So no fancy stuff, just pure simple stuff we'll go through. So the first one, production builds. If you're not building in production, you're doing it wrong. So the benefits of that, you get the ahead of time compilation, you get the minification, and it removes a lot of never executed code paths. So if you write really bad code, it will get rid of all that, and won't run change detection twice. A lot of the time when you're ng serving, the reason why you get the expression after changed error is because it runs the change detection twice. So you'll find that when it runs in production, you'll actually get an increased benefit in that. You won't see it when deving, but you'll get a bit of a benefit. To do it, ng build -- prod, easy as that. The second one, lazy loaded modules. This kind of improves the speed at which the page loads initially. So what it will do is every single feature module you have, if you put those inside lazy loaded modules, they'll only load the moment you hit that root. Another benefit of that is as well as the security, because the code around it won't actually load until you've done that. So if you put a can load around that, a can load guard around that, you won't actually expose that code to users unless they're allowed to. I just wanted to add that little bit, even though it's not a performance thing, it's a really good benefit to have around those lazy loaded modules as well as the performance. Templates, functions versus pipes. Functions and template expressions, they're actually exposed every time the change detection runs. So if you have a function which goes through a large object to get a value out of it, it will actually lock up the UI and actually to perform that. And you'll get that every time you move your mouse around that screen, every time you do a click, every time you do something. If you do pipes instead, the benefit of that is it will only run that code once the reference has changed, once the input has changed. Another benefit I find using those pipes is they're actually a lot easier to test than the functions are as well. Because a lot of the time you write pure pipes and instead of impure pipes, you will find that they're a lot easier to test. Unpush change detection. This one's a bit difficult to implement if the code you're writing manipulates the reference. Because the way the unpush change detection works, it will only run the change detection once the inputs are referencely changed. So if you manipulate that object inside that component, what you'll find is you'll do that action and nothing will actually change on the view. So just be careful if you're going to implement unpush change detection. Really good if you have like large wizards and you only want one part of it to change in the view, because what you'll find is if you have it all running, it might slow down for a sec as it tries to update all the views. Track by functions, as well as the pipe one being one of the biggest things I've found to improve performance really quickly. Track by functions are probably the other one that works really well. If you have large lists, especially ones that have a lot of data in them, if you do a lot of addition, deletion, as well as moving, you'll find the page locks up for a second, or when you scroll in, it will lock up. And the reason being is because of these DOM manipulations. Track by functions are really quick to write as well. It's mainly just writing that track by, providing a function, and the function just takes in the index and the item, and then just providing a unique identifier to return. A quick one with this, be careful using index. I found using index that a lot of times it won't actually update and you'll just get nothing happen. So track by is a really good one, but be careful when using it and make sure you definitely have a unique identifier. This one, you'll see a massive benefit, especially if you have those large lists. So I've added some not so quick changes because I think they're really important to keep an idea around them and make sure that if you reach a point in your code where something big's happening, it might be worth moving to these. So web workers is a big one. We don't really use them that often. I know one product uses them, but the reason why they're really good is because of long running tasks and computations moved off the main execution thread. So these are really good if you're trying to do really big computational stuff inside the UI if you need to, like large object manipulation. I mean, really, you kind of argue, should it be in the server? But if you have to do it in the client, then web workers are the way to go. Some other cool features of web workers off the performance side is it can actually do stuff like if you do lose connection for a second, it can queue up tasks to then execute once you do receive connection again. So you do get more benefits than just performance, but you know, having this ability to run these long running tasks, these computations, is a really big thing, as well as the parallelism. You can actually run them in parallel. You know, a lot of the times we want to make sure that the user has stuff really quickly, and being able to have that will, you know, really benefit them. In addition to web workers, to get a progressive web app, a PWA, you need kind of web workers to do that. The biggest benefits of these are because it caches a lot of the site, you'll get improved page speeds. You'll be able to run that page offline. It's kind of like a quick way to build an app for a mobile device or something, because if it's a PWA, a lot of systems now let you create links directly on the app screen to have that there. So cached assets. And one thing we've done in one app is it can actually request updates from the server to say, have I updated yet? So if a user's on the client, it will actually tell them that the client's updated while they're on the app. So it's a really good way to kind of get them to update quickly, or realize if it's not going to work properly from that point on. So it's a really good benefit to those PWAs. So one thing is, how can we figure out what's causing performance issues? It's kind of difficult. A lot of the time, it's easy to see in like a literal sense. You know, you go to the page, it's really slow, it's stuttering around. That's probably your first visual cue that you'll find if you're having performance issues. Another one is actually identifying why that's occurring. So this is where your performance tools come in, especially on Chrome tools. So it's really difficult at first to understand what's going on here. You'll see a load of blocks, and it'll be really confusing to kind of figure out how do I know what's causing this issue. And if it's in production, it's even worse. Because of that minification on the production builds, you lose all the human readable function names. You'll just see like A and X, and you'll have no idea what they're doing. So you need to kind of look for patterns and translate into the code that's occurring. So I'll do a quick example now. A good example of this is actually the material site. So if I start recording this and I start moving around the page and doing stuff like, doing stuff a user would, what you'll find is you'll record that profile and it will start processing it. And this is where it looks scary because of these big blocks. From having used it quite a lot of times, the thing I find is look for those big blocks that last a long time, when you think, when you see ones that last for a second when it shouldn't be, and try to dive down in what's occurring. So in this sense, hopefully people can see the names and stuff. This is actually production built, so you kind of see that, you get XR, ER. It doesn't really make sense, but if you dig deep enough, you'll start seeing names that kind of do make sense, like for each operations and create embedded view. You kind of start realizing that's maybe something to do with the change detection. NGON in it, you'll start seeing some of the lifecycle hooks, so you can kind of identify where those are occurring. This has helped massively on a few products that we've identified tasks that have been running too much. I know me and Rob have done it before, where we've looked at, I've noticed something that one of the modules that we're taking in, that's running something too much, and because we've identified that, we've been able to take that out and it's improved it really well. As well as another product taking external module to render maps takes a long time, so we're able to kind of work around that. So if you're having a lot of performance issues, I'd definitely spend the time trying to read this or trying to understand what's going on, because it does add a massive benefit to try and tackle those issues. And yeah, that's me. Quick tips on it. Nothing crazy. If there's anything in depth you want me to do, I'll have a look at, especially like the pipes and stuff like that. I'll definitely do a talk on that. But yeah, pipes and track by, definitely the first things I'd look at doing if you've gone past the production build stage, trying to find out to improve that page performance. Slides can be found, and slides can be found on GitHub. And my slides were built in Spectacle. It's one of the new versions, and it's a lot better because it has a CLI. So if you want to have a play around with it, it's pretty cool. Cool. Any questions?
Just going back to that profiling piece.
Which one? Sorry.
Last bit you've just done on performance profiling.
Yeah.
I think it's worth mentioning the Webpack bundle analyzer you can use.
Yeah.
I've used it a few times. It's quite good. Basically, identify things that shouldn't have been included in a bundle or a module.
Yeah, that's definitely something I missed on this. Definitely worth looking at that for sure.